Question 7 is something that many students struggle with. It's worth 9 marks, which is actually very generous for this sort of question, this stage into the paper. Find the coordinates of the points on the curve, and then you're given a big long thing with y's and x's everywhere, at which dy dx is equal to 0. So as soon as I see dy dx, I'm thinking implicit differentiation, because it's going to be near impossible for me to separate that into y equals. So I'm going to begin my implicit differentiation by differentiating y cubed, which is 3y squared dy dx. You can show that using the chain rule, but you should be fine now. 3xy squared, we'll need to use the product rule. If I differentiate 3x, I get 3, so that would be y squared, 3y squared, sorry. And if I differentiate y squared, I get 2y dy dx, so plus 6, 2 times 3, x, y, dy dx. And if I differentiate x cubed, I get minus 3x squared. If I differentiate 27, I get 0. I want to find what dy dx is equal to, so I'm going to factorise out my dy dx. So I have dy dx 3y squared plus 6xy is equal to 3y squared minus 3x squared. And so dy dx is equal to 3y squared minus 3x squared all over 3y squared plus 6xy. And I know that's equal to 0, so my numerator must equal 0. So 3y squared must equal 3x squared, or y must equal plus or minus x. I'm not done there, but I've certainly got quite far. I've found some conditions linking y and x. So I have 2 unknowns and 2 equations, so I'm going to substitute in both y is equal to plus x and y is equal to minus x into my equation to find some values. So I have y cubed, which is just x cubed, plus, and then that would be 3 x times x squared, 3x cubed, minus x cubed is equal to 27, which gives me 3x cubed equals 27, x cubed equals 9, and so x is equal to the cube root of 9, and because y is equal to x, that gives me y is equal to the cube root of 9 as well. When y is minus x, I have minus x all cubed, which is minus x cubed, and then plus 3x times minus x squared, which is plus 3x cubed, minus x cubed equals 27. So I have x cubed equals 27, so x is equal to 3. And because y is minus x, that gives me y is minus 3. And so my 2 sets of coordinates are cube root 9, and 3 minus 3. If I look at my mark scheme for that, I get 1 mark for trying to implicitly differentiate, and then 2 more marks for doing that implicit differentiation correctly. I get 1 mark for setting dy dx equal to 0, so I could actually just sub that into this equation here. That makes my life a little bit easier. 1 mark for solving that to get a condition linking y and x. 1 mark for substituting either variable into the original equation. 1 mark for solving each set of equations. And then 1 mark for writing out my coordinates. And that's a nice 9 marks towards the end of section A sorted.